Now, I shall talk about learning checks. Learning checks are there. We can read it from here PDF. GM line, I have already given that commands and plotted the results, and these are the line checks. Learning checks are there in the book of Kim and Ismay. Why should line graph be avoided when there is not a clear ordering of the horizontal axis? Now, you can think, why are line graphs frequently used when time is the explanatory variable on the x axis? Plot time series of variable other than temperature of New York airport 1st January 2, and then summary. Line graphs are useful when x axis has time axis. So, this is all about line graphs. Now, I am going, say for example, if you want, instead of temperature, suppose you want, see, names early January weather, early January weather. So, instead of, say for example, if we want to look into the visibility instead of temperature, if we want to look into the visibility, so what we have to select here? Visib. So, y is equal to visib. And see what you get, visibility. So, this is the visibility graph. And suppose we want humidity. So, humid, just you have to change here only humid, and see, this is the humidity graph, this is the humidity of the data. So, all these changes you can make. Now, I would like to keep it as temperature in Fahrenheit. Now, histogram. In a histogram, temp distribution is studied. In a histogram, distribution of temperature is studied. In other words, number one, what are the smallest and largest values? These are the things which we observe in a histogram. What are the smallest and largest values? What is the center or most typical value? Then how do the values spread out? What is the range of spread? What are frequent and infrequent values? So, these are some of the features of a histogram. Histogram, actually it makes the basis of a model, a distribution, and that frequency distribution is the foundation of, it provides foundation for statistical inference. A histogram is a plot that visualizes the distribution of a numerical value in as follows. Number one, we first cut up the x axis into a series of bins, where each bin represents a range of values. So, this is the first step. Second step, for each bin we count the number of observations that fall in the range corresponding to that bin. Then for each bin we draw a bar whose height marks the corresponding count. So, these are the basics of a histogram. Now, histogram via GOM underscore histogram. So, let us have a histogram of temperature in the weather data frame. ggplot data is equal to weather mapping AES x is equal to temperature plus GOM histogram, and this histogram is here which we have got. But here there is no border. So, what we have to do? GM histogram we have to give the additional argument color is equal to white. So, it gives border color white. See, this gives border color white. We can fill in the bins. See, these are the white because of white watercolor. White, see. First we run this. Here there is no argument given in the GM histogram. So, we run and we are getting this kind of histogram. But if we want here borders, so we have to give the additional, the rest of the command are same. The only GM histogram color is equal to white and fill is equal to steel blue. So, here filling is steel blue and these borders are white. Now, adjusting the bins and bin width, number of bins and bin width, these are the two important characteristics of a histogram. Bins are these are the bins, these are the bins, these are bin 1 bin, 2 bin, 3, 4, 5. So, these are the bins, and bin width is this width of the histogram, just I would like to go there. See, these are the bins, these are bins, and this distance is bin width, So, adjusting for bins and bin width, let us improve this by adjusting the number of bins in our histogram in one of the two ways. Number 1, by adjusting the number of bins via the bins argument to GOM histogram. Number 2, by adjusting the width of the bins via bin width argument to GOM histogram. With 40 bins, create a plot with bins is equal to, here ggplot data is equal to weather, mapping is equal to AES, x is equal to temperature plus GOM histogram. Now, we are fixing the bins is equal to 40 and border color is white. So, these are the 40 bins. So, these bins are 40. See, when bins are 40, the interval of the width of the bin has been reduced. Here bin is somewhat different, but here it is 40. Bin width 10, we can adjust bin width. So, here instead of number of, so you have to give only one argument, either number of bins, either you give the bins is equal to, or you have to give bin width. Both of them cannot be given. So, bin width is equal to bin width is equal to 10, and when rest of the commands are same. So, bin width is 10. So, this is the histogram, we get. Learning check. What does change the number of bins from 30 to 40? Tell us about the distribution of the temperatures. Would you classify the distribution of temperatures as symmetric or skewed in one direction or the other? So, here it is left skewed, it is not symmetric. What would be the guess is the center value? So, center value is around, this is around 50, this is around 50. Is this data spread out greatly from the center or close to it? It is not greatly spread out from the center. It is in the range of 0 to 100. So, summary: histogram, unlike scatter plots and line graphs, present information on only a single numerical variable. Specifically, they are visualizations of the distribution of the numerical variable in question. Now, facets. Before continuing with the next of the 5 NG, 5 name graphics, let us briefly introduce a new concept called faceting. Faceting is used when we would like to split a particular visualization by the values of another variable. This will create multiple copies of the same type of plot with matching x and y axis, but whose content will differ. So, here view weather months. So, first I would like to go to here. I have already talked about these graphs and I have already run these. This is with 10 bins, then faceting. ggplot data is equal to weather, mapping AX is equal to temperature plus GM histogram, bin width is equal to 5, color is equal to white, and facet wrap, facet underscore wrap and tilde month. So, it will generate, because there are 12 months. So, it will generate 12 plots. It will generate 12 plots corresponding to 12 months. So, if you run this, see, these are the plots. Better we should look into here, these are the 12 plots. So, this is the temperature of January, this is the temperature of February, this is that of March, April, May, June, July, August, September, October, November, December. So, here in the month of January it is left skewed, whereas in the month of December it is right skewed, whereas in the month of it is the temperature of New York, not any other place. It is the month of April where it looks symmetric, whereas in the month of May it is right skewed. So, these are this is possible because of faceting, facet wrap month, tilde month. So, this is the graph, facet wrap. Fill with 4 rows instead of 3. Here we have 3 rows. So, if we want to have 4 rows, so certainly month n row is equal to 4. So, it will give you 4 rows now, 4 rows, because 3 columns are there and 4 rows. So, this is the January, this is February, this is March, April, May, June. So, if we look into these commands, n row facet wrap tilde month, it will facet with respect to the month, and n row the number of rows should be 4. So, if we run these commands, it is this, these are the 4 rows we are getting. Now, I shall talk about 4th graphics, and that is boxplot. This is the 4th named graphics, boxplot. A boxplot is constructed from the information provided in 5 number summary of a numerical variable. Boxplot via GM boxplot. So, here GM data is equal to weather, mapping AES X is equal to month. So, month is what? Month is in numbers, it is 1 to 12, and y axis is equal to temperature. So, see what happens, that it gives this kind of box plot, because here month is numeric. So, it gives only one box plot, and that is that of temperature, but it is not good. So, here we have to change this x is equal to month, we have changed into a factor variable. Now, after just changing, converting this into a factor month, because here we have just given month. So, after giving just x is equal to month, it gives this plot, which is not required. X is equal to factor month, now it will give the required plot. See, factor month. Now, it has factored the data, and this gives the box plot of January, in which this is the median, this is the first quartile, this is the third quartile, and this is the outlying observation, and these are the whiskers. I have already talked about whiskers. Similarly, this is the temperature of February, and similarly here in the month of May we have a very down temperature, and that is an outlier. And similarly here we are having some extreme observations which are also termed as outliers. So, this is like a faceting, but faceting in terms of the shape of the, say for example, longest variability in temperature is in the month of 11, that is November, and least variability is in the month of August. And see here, this is about symmetric, this is also about, but this one is left skewed, this one is right skewed. So, this one is left skewed, this is almost symmetric, this is right skewed, this is about symmetric, but this one is left skewed. So, note that box plot represents location, dispersion. So, this is the location, and then dispersion, this range of the box plot, this is dispersion, and shape. And shape means whether it is symmetric or not. All the main important aspects of a data. The dark line in the box shows the median. Lower and upper end of the box represents the first and third quartiles. This is the first quartile and this is the third quartile. Length of the box shows the variability. Say for example, here more variability as compared to this one. Lower and upper whiskers are lower and upper vertical lines. So, these are termed as whiskers, which are lower whisker. Lower whisker is equal to maximum of minimum of y. So, it is maximum of minimum of y, or first quartile minus 1.5 into IQR, interquartile range. So, it is maximum of these two. So, it is lower whisker. And upper whisker, here in lower whisker it is max here and it is min here. Here in upper whisker it is minimum, not maximum, and max is inside. So, where Q1 and Q3 are the first and third quartiles represented respectively. IQR stands for interquartile range, that is IQR y is equal to Q3 minus Q1 y. Points outside whiskers are termed as outliers. So, these are the outliers. So, we have talked about the fourth graphics, and that is known as box plot. So, here we can get box plot. So, this is the box plot which is not desired, because here we have not changed this into a factor. Now, in the next graph we have changed into a factor now, because factor is a categorical variable. Now, this is the real picture of the box plot, and I have already interpreted all these things. Now, I shall talk about bar plots. Bar plots. So, before bar plots, I would like to talk about tibble. Tibble is a package and it is a data frame also. It is a package which is developed by Helly Wickham. So, tibble, see what is the difference between a tibble, fruits, tibble, and then inside that fruit is equal to. So, this is the column of tibble. Tibble is just like a data frame, but it has some other features also. Just I would like to run this tibble, apple, apple, orange, apple, orange. So, this is a tibble. Fruit, F-R-U-I-T, fruit, fruits. Here in a data frame, this character, this column fruit is the name of the variable, and this is the column character, this is the character column. So, this character is not mentioned in a data frame, but here in tibble we have just below the name of the variable, it shows what kind of, it is character or numeric or complex like that. So, this is the data fruits. Another data, this is the data frame fruits. Another one is fruits counted. Fruits counted, it is tibble, fruit is equal to, this is the first column, fruit, apple, orange, and here number we are counting how many apples are there. There are 1, 2, 3 apples. So, 3 apples, and how many oranges? Orange, orange. So, there are 2 oranges. So, it gives a data like this. Now, if you print this, it has fruit and the column is character, apple, orange, and number, it is DBL, double precision, it is 3 and 2. So, this is the feature of a tibble, it is not data frame, tibble. Now, bar plot via GOM bar or GOM. So, first I would like to go into the PDF, and here I have already shown these things. Now, bar plot via GOM bar or GOM call. When no a pre-counted form is given, it is GOM bar. When data, no pre-counted form is available with the data, so it counts the frequencies and then it plots. So, it is GOM bar. When pre-counted form is there like this data frame, it calls GOM call, and both will give the same result. So, here it is GOM bar, but here it is GOM call, fruits counted. So, and x is equal to fruit and y is equal to number. Here we need only one argument, that is AES x is equal to fruit, but here we need both, x is equal to fruit, and y is equal to number, and these are the apple and orange, and these are the numbers. So, this is GOM bar. Now, I would like to go into these. When no pre-counted data frame is available, it is fruits. So, there is no count, it is not given in the form of count. So, we use GOM bar and we run this here, AES x is equal to fruit, and it generates the box plot. But when fruit counted, we have when fruits counted, when this kind of data in which one column gives apple, fruit number, apple, orange, and then number 3, 2. So, it gives the data is given in the form of two columns, one is in fruits and other one is number. So, if data is in the form of counted this format, then we have to use GOM bar, not GOM. We have to use GOM call, not GOM bar. Fruits counted, data is fruits counted. So, we have to give GOM call. So, but output of course will be the same. Now, I would like to give a break and I shall continue in my next video about the GOM call or bar.